For over a century, humanity has pondered the enormous disappearance of dinosaurs from the face of the Earth. How could creatures that ruled the planet for tens of millions of years suddenly vanish? What kind of event could have destroyed these giant reptiles that once seemed almost indestructible? This mystery remains one of the most fascinating and, at the same time, most terrifying chapters of prehistory. Although multiple theories exist, each with its own specifics, evidence, and criticisms, the answers are far from black and white. Scientists continue to uncover layers of events that, like a mosaic, piece together the complex picture of one of the greatest catastrophes in Earth's history. Let us journey back to the Cretaceous period, to an age when gigantic carnivores roamed the land, plant-eating titans with necks longer than buses grazed in herds, and the skies were ruled by bizarre, winged creatures. Step by step, we will examine what may have happened all the way to the dinosaurs' final day. One of the most widely discussed and probable theories is the catastrophic impact of a massive asteroid that struck the area of what is now the Yucatan Peninsula in Mexico. This collision, which occurred around 66 million years ago, released energy equivalent to billions of atomic bombs. It created the enormous Chicxulub crater, now buried under layers of sediment, and is considered definitive evidence of the event. The impact unleashed vast amounts of heat, dust, and gases, leading to planet-wide climate changes and a prolonged blockage of sunlight. The aftermath set off a domino effect: widespread wildfires, ocean acidification, the collapse of food chains, and a sudden global cooling. Without sunlight, plants began to die, cutting off food for herbivorous dinosaurs and, in turn, for carnivores. Even the mightiest creatures of that age could not survive such extreme conditions. The shift in climate was so rapid that most species had no chance to adapt. At the same time as the asteroid impact, massive volcanic eruptions were also occurring in what is now India. This volcanic system, known as the Deccan Traps, was active for thousands of years and released vast amounts of carbon dioxide, sulfur, and other gases into the atmosphere. These emissions drastically altered the chemical composition of both air and oceans, causing an extreme greenhouse effect that raised global temperatures and disrupted the climate. While the asteroid may have been the immediate cause of collapse, the volcanic activity likely weakened ecosystems long beforehand. Increasing temperature fluctuations, acid rains, and declining biodiversity had already slowed the planet's ability to regenerate. In combination with the asteroid, this amounted to a deadly double blow: one massive shock and long-term ecological pressure that drove life into a mass extinction. Climatic fluctuations, whether caused by volcanic activity, asteroid impact, or a combination of both, had a devastating effect on the environments dinosaurs inhabited. Rapid cooling or extreme warming disrupted the natural order. Many plants began to die off, dismantling the foundation of the food pyramid. With less vegetation, herbivore populations shrank, followed by carnivores. Animals that had evolved over millions of years in stable ecosystems were unprepared for such abrupt and drastic changes. Food chains, which relied heavily on specific plants and animals, collapsed like a house of cards. Especially for large dinosaurs with massive energy needs, famine led to swift extinction. During the late Cretaceous period, the long-term geological process of breaking apart the supercontinent Gondwana continued. As tectonic plates gradually separated and new oceans formed, the face of the planet changed. Previously connected biomes became isolated, affecting species migration, food availability, and ecosystem stability. New ocean currents and patterns altered temperatures and humidity across regions, deeply influencing the evolution of flora and fauna. These geological changes, though slow, disrupted the balance of natural conditions. Dinosaurs accustomed to specific environments faced new challenges: colder winters, scarcer food, or invasive species from other areas. The breakup of continents indirectly contributed to the vulnerability of dinosaurs to later threats. With ecological imbalance came greater susceptibility to disease. In the final phase of the Cretaceous, increased migration, climate stress, and habitat loss could have helped spread viruses, bacteria, or parasites. Such outbreaks could decimate animals living in close proximity, especially when their immunity had already been weakened by starvation or temperature stress. Among social dinosaur species, epidemics could have caused catastrophic losses. If a disease was both deadly and fast-spreading, it could wipe out entire populations in a short time. While this theory is hard to prove directly through fossils, many paleontologists consider it an important piece of the extinction puzzle. As continents split and seas reconfigured, numerous animal species moved into new territories. Some of these were not part of the original ecosystems and had no natural predators in their new environments, allowing them to spread uncontrollably. These invasive species could compete for food, displace native species, or introduce new diseases to which local fauna had no immunity. The competition for resources and space became increasingly fierce. Invasive reptiles, mammals, or even insects could have disrupted existing food webs, weakening the native dinosaurs. Combined with other stressors, this was another blow that reduced their chances of survival. The scientific community still debates whether the extinction of dinosaurs was a slow, gradual process driven by long-term environmental change, or a sudden catastrophe that altered everything in just a few years or decades. Supporters of the gradualist view point to fossil layers showing a decline in diversity before the asteroid impact. Others highlight the abrupt transition marked by the global iridium layer, a rare element from outer space. The truth may lie somewhere in between. It is highly likely that dinosaurs were already weakened by climate shifts, volcanic eruptions, and ecological stress, and the asteroid was simply the final blow. Thus, their extinction may have been both gradual and sudden at the same time. In the late Cretaceous period, small mammals began to emerge onto the scene. Though they lived inconspicuous lives beneath the foliage and in burrows, their adaptability, nocturnal habits, and rapid reproduction gave them notable advantages. While most dinosaurs were dependent on specific ecosystems and had high demands for food and territory, mammals were more flexible, capable of surviving extreme conditions and taking advantage of any opportunity. After the catastrophe that struck the dinosaurs, mammals quickly spread into the newly vacated ecological niches. Some theories suggest that even before the extinction, mammals were already beginning to compete with smaller dinosaurs for food and shelter. While this competition likely wasn't the primary reason for extinction, it may have added pressure on already weakened species. Extinction wasn't limited to land. The oceans, which cover most of the planet, experienced their own crisis. Due to climate fluctuations and changes in the chemical composition of seawater, colonies of plankton began to die off. These microscopic organisms formed the foundation of the marine food chain. As they disappeared, the entire oceanic ecosystem began to collapse from the bottom up, affecting small fish all the way to large marine predators. This collapse had consequences for land-based species as well. Many dinosaurs lived near coastal areas and were part of interconnected ecosystems dependent on marine life, whether through food, climate, or migration. Once the balance of the oceans was disturbed, it had ripple effects across the continents. Disruptions in the carbon and oxygen cycles of the seas had global consequences that reached even the most distant inland habitats. Fossil records are among the most important sources of information about dinosaur extinction. Through careful study of the rock layers marking the transition between the Cretaceous and Paleogene periods, scientists have determined that around 75% of all species vanished in a relatively short time. Across the globe, a thin layer rich in iridium, a metal rare on Earth but common in space, has been found. This so-called iridium layer is considered direct evidence of an extraterrestrial impact. In addition, layers of ash, carbon, and signs of widespread fires point to massive ecological disasters. In some places, fossilized tracks of the last dinosaurs have been found, abruptly ending with no further continuation. These fossils serve as silent testimonies of the final days of these creatures and help map the scale of the catastrophe that engulfed the entire planet. Some hypotheses focus on potential reproductive problems in the final stages of dinosaur existence. Due to environmental stress and pollution, embryonic development may have failed, eggs might not have developed properly, or hatchlings may have died shortly after birth. Temperature changes could have disrupted the balance between male and female embryos, as happens with some modern reptiles. When low survival rates among hatchlings are combined with other stressors, such as food scarcity, disease, or climate change, a population cannot sustain itself. Even if adult individuals survived for some time, the absence of new generations sealed their fate. This quiet mechanism could have been slow and subtle, and all the more effective because of it. One often overlooked but crucial factor in the extinction of dinosaurs is the change in atmospheric chemistry. Volcanic activity, asteroid impact, and widespread fires released enormous amounts of gases, carbon dioxide, sulfur dioxide, methane, and others. These gases could have caused rapid global warming, the thinning of the ozone layer, and most importantly, a drastic decline in air quality. Reduced oxygen levels, combined with toxic fumes and fine dust particles, could have severely impacted the health of dinosaurs. Many species had respiratory systems adapted to specific conditions, and a change in air composition could have led to stress, weakened immunity, and organ failure. At a time when ecosystems were already collapsing, this added burden may have hastened the overall collapse. The extinction of the dinosaurs did not mark the end of life on Earth. On the contrary, it opened the door to new forms of existence. With their reign ended, the planet began to transform. Forests changed, mammals occupied abandoned habitats, birds began to diversify, and new fish species emerged from the seas. This evolutionary wave was made possible by the vast number of ecological niches left vacant by the giant reptiles. Large dinosaurs had dominated the land for over 160 million years, but once ecosystems collapsed, their ability to adapt to new conditions was severely limited. Their size, metabolism, and slow reproduction became disadvantages. In contrast, small, rapidly reproducing, and less demanding species survived, and with them, a new age of life began. The end of one era became the beginning of another. The extinction of dinosaurs is not only a scientific mystery, it is also a cultural symbol. Their sudden disappearance evokes curiosity, fear, and awe. The immense power of nature, capable of ending the existence of such mighty creatures, reminds us of the fragility of life and the ever-changing conditions of our planet. In many cultures, books, films, and legends, dinosaurs have become metaphors for extinction, greatness, and impermanence. Though dinosaurs are gone, they left an indelible mark in fossilized bones, in human consciousness, and in the questions we continue to ask. Why did they die out? What should we learn from it? And most importantly, how can we avoid a similar fate? Their story is not just about the past, but also about the future. It is a warning that remains relevant. Although most dinosaurs went extinct, one branch survived and still lives among us: birds. Today, we know that many small theropod dinosaurs had feathers, lightweight skeletons, and other features linking them directly to modern birds. At the time of the extinction at the end of the Cretaceous, only the smallest, most adaptable, and most mobile forms survived. These would later evolve into the birds we know today. It is fascinating to realize that when we watch a sparrow, eagle, or hummingbird, we are looking at living descendants of ancient dinosaurs. Their survival was likely due to a combination of small body size, omnivorous diets, the ability to fly, and nesting in sheltered environments. Birds form a direct biological bridge between the prehistoric world and our present. The extinction of the dinosaurs meant more than the end of one group of animals. It was a transformation of the entire biosphere. Vacated niches in every ecosystem were gradually filled by other groups, leading to new food chains, forms of species cooperation, and evolutionary strategies. Mammals spread, birds diversified, and insects and plants began to evolve in new directions. This transformation took millions of years and resulted in the ecosystems we know today. In a paradoxical way, extinction paved the way for life as we now experience it, including the rise of humans. Without this mass extinction event, the planet might be populated by completely different organisms. It reminds us that even catastrophes help shape the future. Many misunderstandings and distortions have accumulated over the decades in popular culture regarding dinosaur extinction. One of the most common myths is that dinosaurs were primitive, unintelligent, and unable to adapt. In reality, they were incredibly successful and lived on Earth for over 160 million years, far longer than humans. Many had highly developed senses, complex social behaviors, and adaptations that made them dominant life forms of their era. Another misconception is that all dinosaurs disappeared instantly and completely. As we've seen, birds are their direct descendants. Moreover, extinction was not necessarily a one-day event. It may have taken thousands of years. In some movies, the asteroid is shown as an explosion that instantly wiped out all life. In truth, it was a combination of climatic and ecological changes with complex consequences. Oversimplifying reality often obscures the true intricacy of the events that shaped our planet. It is truly fascinating to consider how different the world would be if dinosaurs had never gone extinct. Many paleontologists believe that without this catastrophe, the conditions necessary for mammals to evolve into human-like forms would never have arisen. Large reptiles would likely have continued dominating the land, while mammals remained small, nocturnal creatures. Human civilization, knowledge, and history might never have existed. Thus, the extinction of dinosaurs is not only a story of the past, it is a prerequisite for our very presence. Every tree, bird, frog, or human is part of a new ecological world born from the ruins of a prehistoric colossus. The disaster that changed the world back then created an entirely new beginning. In a way, we ourselves are the result of the end of one great age. The end of the dinosaurs was not the only mass extinction in Earth's history. In fact, at least 5 such global events are known. The most devastating was likely the Permian-Triassic crisis about 250 million years ago, during which up to 95% of marine species and 70% of terrestrial organisms died out. Compared to that, the extinction of the dinosaurs, while dramatic, was milder, though it marked the beginning of a new age of life. Comparing these extinctions reveals that they are often caused by a combination of factors: climate changes, volcanic activity, continental shifts, and cosmic impacts. The extinction at the end of the Cretaceous is unique in how well it is documented and how dramatically it altered the course of evolution. Each mass extinction has been not only an ending, but also the start of a new chapter, and the one after the dinosaurs eventually led to us. The first theories about dinosaur extinction appeared as early as the 19th century, but for a long time, they were based more on speculation than evidence. Some researchers believed that dinosaurs were simply lazy. Others thought they were wiped out by mammals or even a change in gravity. It was not until the 20th century, especially through paleontologists like Lewis and Walter Alvarez, that the asteroid impact theory emerged, backed by compelling evidence. Science, however, continues to evolve. With advances in geology, chemistry, and computer modeling, new insights continue to emerge, refining and correcting older ideas. Today, most scientists agree that the extinction was caused by a combination of factors, with the asteroid as a catalyst, but acting upon an already weakened biosphere. Science constantly rewrites the story of the past as new data becomes available. It is a living, ever-changing process. Alternative scenarios remain a captivating topic of both science fiction and serious speculation. If the mass extinction had never happened, the world today would look completely different. The dominance of large reptiles would likely have prevented mammals from rising to prominence, and thus prevented the evolution of humans. Ecosystems would be structured differently, continents inhabited by very different creatures, and there might even be intelligent dinosaur-like beings with their own civilization. Ecologically, such a planet could have been stable but completely alien to us. Trees might never have been cut, cities never built, or built by beings with claws, feathers, and scales. This thought experiment also highlights how fragile our place in Earth's history truly is. Without one single catastrophe, we would not be here. The story of dinosaur extinction is not just about the distant past. It is a universal narrative about the fragility of life, the power of nature, and the unpredictable turns in the planet's evolution. It was not the result of a single cause, but a chain of events that led to a tragic end. An asteroid impact, volcanic eruptions, climate fluctuations, atmospheric changes, weakened ecosystems, and the rise of mammals, all combined to break the reign of creatures that had ruled the world for over 160 million years. Yet their disappearance also opened the door to a new beginning, the evolution of birds, the rise of mammals, and eventually, the emergence of humans. Whenever you see a bird flying across the sky, remember, you are witnessing the living legacy of one of prehistory's greatest chapters. And if you ever come across a fossil in a museum, know this: it is not just a stone. It is a witness to the end of a world that gave birth to our own. If you enjoyed the video, I would be truly grateful if you subscribed. It helps bring prehistoric and dinosaur content to more people. Thank you.